Today's lesson is about the derivative, and at the end of this lesson, you should be able to differentiate a function based on the definition of the derivative, or to use what is known as the four-step rule method or the increment method. The process of finding the derivative of a function is called differentiation, and the branch of calculus that deals with this process is called differential calculus. Differentiation is an important mathematical tool in physics, mechanics, economics, and many other disciplines that involve change and motion. The derivative of the function y, the f function of x at point P on the curve is said to be equal to the slope of the tangent line at P. Thus, the derivative of the function f given by y is equal to the f function of x with respect to x at any x in its domain is defined as follows. The derivative of y with respect to x is said to be equal to the limit of delta y over delta x as delta x approaches 0, or that is the limit of the difference quotient, the difference between f of x plus delta x and f of x to be divided by delta x as delta x approaches 0. This is provided the limit exists. Now, the following symbol will define the derivative of y with respect to x as well. So, aside from the notation dy dx, you can have df of x dx, or the derivative of f of x with respect to x, or you can use the prime notation. So, you have y prime, or you have f prime of x, or you can use the capital D notation to denote the differential operator. So you can have capital dy or capital dy subscript x. All of these notations would define the derivative of y with respect to x. The statement given us earlier can be viewed geometrically as follows. Consider having the graph of y function of x that's given by the blue curve, and on this curve are 2 points P and Q with the corresponding coordinates. Now, please take note that if P and Q are connected with a line, then we come up with a secant line. A secant line is just a line that connects any 2 points on the curve. Now, if we will let delta x approach 0, geometrically that can be done by moving Q to approach P. So you move Q closer and closer to P, the secant line tends to rotate, and that the limiting position of the secant line would be the tangent line. So that the limit of delta y divided by delta x as delta x approaches 0, or the limit of the slope of the secant line as delta x approaches 0, would be the slope of the tangent line. Based on the definition of the derivative, we can determine the derivative of y with respect to x by doing basically 4 steps. First is to define f of x plus delta x. The second step is to get the difference of the function f of x plus delta x minus f of x. The third step would be to divide that difference by delta x. And finally, the fourth step, to determine the limit of this ratio as delta x approaches 0. Because in this expression we are using the increment delta x, then the procedure is also referred to as the increment method. And because we are doing 4 steps, this procedure is also referred to as the 4-step rule. So to summarize what the 4 steps are, then we do the following. Step 1 is to substitute x plus delta x for x and y plus delta y for y in the expression y equal to function of x. Step 2 is to subtract y equal to function of x from the result of step 1 to obtain delta y, expressing this in terms of x and delta x. Step 3 now is to divide the expression that is obtained after doing step 2 by delta x, and step 4 is to determine the limit of the expression obtained in step 3 as delta x approaches 0. Okay, let us now work on a particular example that is differentiating the function f of x equal to 3x squared minus 2. To determine the derivative of the function f of x given by 3x squared minus 2, we will be basically doing 4 steps based on the definition. So the first is to define y plus delta y, which is f of x plus delta x given by 3 times the square of x plus delta x minus 2. Step 2 is to obtain the difference delta y, given by the difference between function f of x plus delta x and f of x. So that will be the difference between 3 times x plus delta x squared minus 2 and 3x squared minus 2. Now, before moving on to step 3, it is suggested that you simplify the expression obtained in step 2. So, in the process, you expand on x plus delta x squared to give you this trinomial, so that what you have here now will just be the difference between these two expressions. Okay, and if these terms are multiplied by 3, then we will have 3x squared plus 6x delta x plus 3 delta x squared, then minus 2 minus 3x squared plus 2. Simplifying this expression by combining similar terms together would just give us a 6x delta x plus 3 delta x squared. Okay, now at this point we are ready to divide delta y by delta x, dividing 6x delta x plus 3 delta x squared by delta x to give us 6x plus 3 delta x. Now for the last step, we have to determine the limit of delta y over delta x as delta x approaches 0, or the limit of 6x plus 3 delta x as delta x approaches 0. Now, please take note that x and delta x are two different variables. So that as delta x approaches 0, it is only this factor that will be approaching 0 and not x. And therefore, the limit of 6x plus 3 delta x as delta x approaches 0 would be 6x. Okay, so what we're saying here is that the derivative of 3x squared minus 2 with respect to x is just equal to 6x. In summary, the derivative of a function f of x with respect to its independent variable x given by the symbol dy dx is defined as the limit of delta y divided by delta x as delta x approaches 0, or is equal to the limit of the difference quotient, the difference between f of x plus delta x minus f of x divided by delta x as delta x approaches 0, provided that this limit exists, and that geometrically this is interpreted as the slope of the tangent line to the curve of f of x at a given point. Okay, so with this, I hope that you will be able to determine now the derivative given a function y equal to f of x. Now, this will be all for today. I will see you in the next lesson.